We're going to take a look at our final lesson for quadratics, and what we're going to start off with is a little bit of review of something we did a couple lessons ago when we were writing linear equations. We talked about how you can take this intercept form, is what we called it, and put it into standard form using something called the FOIL method. Remember, the FOIL method stands for first, outside, inside, and last. Meaning, you multiply the first term times the first term. You end up with x squared. You multiply the outside terms. That is 5 times x. You multiply the inside terms. Negative 4 times x. And then you multiply the last one times the last one. Or the last one in this parentheses times the last one here is negative 4 times 5, which is negative 20. When you add 5x and negative 4x together, you get 1x. And so now I've taken intercept form and I've put it into standard form. What we're practicing this for is to make sure that you understand that you can do that, first of all, and because today we're going to be going backwards. Because one of the things that we noticed about the intercept form is that these two little factors, these two factors are things that multiply together, x minus 4 times x plus 5, those are easier than the quadratic together as far as they are linear factors. It also gives me two specific points when we're talking about the graph, the intercepts. What we're going to look at is today going backwards. It's actually a process that is called factoring. It means we're going to take this and we're going to split it up. X squared came from the x and the x. The negative 20 came from the negative 4 and the 5 multiplied. Notice that's all 4 spots. The middle number 1x comes from a combination of the outside 5 times x and the inside negative 4 times x to get 1. You could not use 2 and 10 to get 1. It has to be this negative 4 and 5 to get 1 in the middle. I'm emphasizing that for a reason, because in a little while, like I said, we're going to be going backwards and taking standard form, which is a fairly ugly quadratic, and we're going to be splitting it apart into what we call intercept form. Because what this is going to do is this is going to give us the ability to solve equations that are quadratics. Let's practice one more of those. Actually, let's do 2 more. Let's take a look at this one and let's multiply this together. Notice x minus 2 squared is the same thing as x minus 2 times x minus 2. So here's my FOIL method again. Notice what happens. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x again is another negative 2x. Negative 2 times negative 2 is positive 4. That gives me x squared minus 4x plus 4. Notice the x squared came from the x and the x. The positive 4 on the end came because it was a negative 2 times a negative 2. That's important. And the middle, negative 4x, also came from the outside, negative 2x, and the inside, negative 2x, like the previous problem. Then we can also distribute this negative 3. So we have negative 3 times x squared. Negative 3 times negative 4x is positive 12x. And negative 3 times 4 is negative 12. Notice that that gives me a standard form. And guys, what we have here is we have this process of the multiplication. Yes, we use that little term FOIL method, but it's multiplying this together. In a little while, we're going to be going backwards, like I said, in a process that's called factoring. Factoring is basically the opposite of multiplication. It is splitting something up into the factors. The reason we're doing that is because it's going to help me find solutions to equations. So let's do one more. X plus 6 times x minus 6. X times x is x squared. X times negative 6 is negative 6x. Positive 6 times x is positive 6x. And positive 6 times negative 6 is negative 36. X squared minus 36 is my final answer. Notice on this one, the x squared comes from the x and the x. The negative 6 times the positive 6 gives me the negative 36. But because it's negative 6x and positive 6x, that's the outside and the inside, it cancels out the middle. There is no middle term. That's important because that could come back and help us later on when we're splitting it back apart. So, this is one way to take intercept form and put it into standard form. Some people think that's easier to find the vertex that way because there's that little formula I gave you, negative b over 2a. Some people like the intercept form better and find the vertex halfway between the intercepts. So this gives you a way to do both. But the key thing that I was trying to show you is that we're also going to be working backwards through this. Because these pieces, or these factors we call them, are smaller, easier, linear factors of a quadratic. These smaller, easier pieces are linear factors of a quadratic, that mx plus b. That means I can break apart a quadratic that has x squared into, because we're going to go backwards on this, I can break it into some easier pieces. Here's why. What we can do is we can use that to take standard form equations and split them apart into factors, and we can use intercept form to help us find solutions to equations. Before we do that, one thing you do need to make sure that you always do first is check and see if there's a common factor you can divide out of everything first. So we're going to take a look at this little simple rule here real quick before we get into the uglier factoring. So factoring basically, guys, is the opposite of what we just did, the opposite of multiplying. So when we factor, we're going to divide something up or split it apart. Now that means if you look at these two right here, you can divide a 2 out of both of them right from the very beginning. And you can take an x out of both of them. Now when I say take an x out, I literally mean you're dividing 2x squared by 2x, because it's got an x squared in it. And you're dividing the 2x by 2x because it can divide evenly into both of those. But watch what happens when you do that. If you divide 2x squared out, it's going to be just 1, and one of the x's is going to cancel, so it's just going to be 1x left over. 2x divided by 2x is easy. That's 1. Notice it's just like reversing the distributive property, because what is 2x times x? 2x squared. 2x times 1, 2x. So that is taking it and it is dividing the 2x out. You could also, on this one, divide negative 3 out. Now there's a reason I chose negative 3 instead of positive 3, because the negative 3 will make this 1x squared. When I divide negative 3x squared divided by negative 3, it's just 1x squared. Makes it nice and pretty here. What is 6 divided by negative 3? That's negative 2x. What is 9 divided by negative 3? Negative 3. And so then what we can do after we've divided out that number, what we're then going to look at is, can we split this up further by splitting this up using our reverse of the FOIL method. It's called factoring. All of this is. So think about this, guys. I'll go back just a little bit here, back in time. You remember the factor trees that you used to do back in the day in middle school probably? You split this up into 2 times 6, and then you split up the 6 into 2 times 3, and you said at the very bottom that these are prime numbers, so 2 times 2 times 3, in other words 2 times 2 times 3, or 2 squared times 3 is another way to say it, gives me 12. Guys, that's what we're doing with these quadratics. And I know it sounds like I'm trying to oversimplify it, but it is truly based off of, can you multiply or divide some numbers up while thinking about multiplication? And can you add and subtract? And I know that sounds like I'm, again, oversimplifying it, but that's what we're doing when we split these guys up. So, how do I split this up? This is where you've got to think about what I showed you just a few minutes ago about multiplying. So let's go to an example of splitting this up. Notice I can't divide anything out of this because there's only a 1 here. I can't divide anything out of 12 and 28 and 1. So think about what we did a minute ago. This x squared right here, where did it come from when we multiplied? It came from an x here and an x here. The negative 28, where did it come from when we multiplied? It came from whatever was here times whatever's here. That's that first, outside, inside, last, or F and L specifically. But it's got to be things that multiply to give me 28. It can't be just random numbers. So it's got to be 1 times 28, or 2 times 14, or 4 times 7. Those are the only factors of 28. There are no other factors of 28. Now, usually I'll get somebody here says, what if you did 16 and 12? 16 times 12, that's not factors of 28. Guys, when we say factors, think of those factor trees. It has to be 1 times 28, 2 times 14, 4 times 7, because that's what the FOIL method is doing, is multiplying. So it's taking this and saying, okay, it has to be one of these pairs. It also, look at the negative 28. What does that tell me? It also has to be a positive number and a negative number, because a positive times a negative is a negative. It can't be both negative. It can't be both positive, because those would end up giving me a plus 28. But how do I pick what goes there, Mr. Harrison? This is where the middle number comes into play. And if you think back to what we did when we were multiplying earlier, I said, guys, look, the 5x and the negative 4x give me the 1x. But that came from the O and the I part of the FOIL method, the outside and the inside. So if you look, oh goodness, didn't mean to do that. If you look at the middle number, negative 12, whatever I put here times x, and whatever I put here times x, it's going to be negative, has to give me 12. What do you mean? Well, look at your numbers. You've got 2 and negative 14. That would be 2x and negative 14x if we multiplied, which is negative 12x when we add. You just split it up. Now, some of you may be thinking, well, Mr. Harrison, can I just do that with 4 and 7? Well, let's look. If I put x plus 4 and x minus 7, that'll work for x times x. That's x squared. That'll work for 4 times negative 7. That's negative 28. But that will not work when you do x times negative 7. That's negative 7x. 4 times x, that's 4x. That is not negative 12. So this will not work unless you use the proper numbers. So it has to be numbers that multiply and give me negative 28 and add up to negative 12. Let's do it again. X squared minus 2x minus 48. Again, I can't divide anything out of all three of them. So I split this guy up into x and x because of x squared. That's what's always going to happen when it's just 1x squared. I'll show you what happens when it's not in a second. It's got a negative 48. So whatever's here and whatever here has to be first a plus and a minus, because it has to be negative. And it has to be factors of 48. Well, what's factors of 48? 1 times 48 is 48. 2 times 24 is 48. 3 times 16 is 48. 4 times 12 is 48. 6 times 8 is 48. Now, guys, if you don't know those in your head, it's okay. I'm not saying that you can't use a calculator there. I'm just trying to save you some time in this video. So when you do that, look at those numbers. 6 and 8, 4 and 12, 3 and 16, 2 and 24, 1 and 48. If I put them here and I put them here, whatever I put in the spot that goes here times x, and whatever I put in the spot here times x, That's the outside and the inside of my FOIL method. Remember, we're multiplying. But I'm going backwards and splitting it up. But I can still think about multiplication. Whatever I put here and here has to multiply to 48. And it has to add up to -2. So yes, hopefully some of you figured it out by now. +6 and -8 would give me 6x and -8x. Now here's the thing. I don't want you to write all of this junk all over the place on this problem. I'm showing you what it looks like if I do write all that. But here's what it looks like if I don't. First of all, notice on this one, I can divide -1 out of all of them, and it'll make it a little bit easier. X squared plus 5x and -14. Then I'm going to take it, I'm going to split this up. I'm not going to write down all my little pretty colors everywhere this time though. X squared splits up into x times x. -14 has to be a plus times a minus. Don't worry about the negative out in front. It's kind of chilling out in front like the numbers where we saw the graphs opening up and opening down. What are the factors of 14? Well, this one you might want to write on the side. 1 and 14, 2 and 7, but I got to get 5 in the middle. So I use +7 and -2 to get 5, because that's 7x and -2x. Notice, now I've split this up into this times this times this equals what I started with. So the factoring method is splitting it apart basically from that standard form into that intercept form. In just a minute, that's going to mean something really important to us, because remember we set these things equal to 0 to find out where the y value was 0 on the x-axis. Now it's going to mean something a little more to us when it comes to equations that we're solving. So let's look at what happens when the numbers get a little bit uglier, meaning something like this. Excuse me. Notice right here, this one, you cannot divide the 3 out. That means this 3x squared has to come from here and here, but it can't be just x and x this time. Because I couldn't divide the 3 out, that means it has to be the factors of 3, 3x times 1x. How do I know it's 3 times 1? Because, guys, that's the only way to get 3. 3 times 1. Also notice that the last number, +10, that's important to notice, it's positive. Anytime that last number over here is a positive number, that means my sign of this number and this number is going to be the same. The way you figure it out is you look in the middle. That means both of them have to be minus to get a -17 in the middle. We're not at that point yet, but I'm kind of glancing over here. Anytime the last number is positive, that's the sign for both of them. What are the factors of 10? 1 times 10 or 2 times 5? Now you may look at those and you may think about the problems we just finished and say, there ain't no way. 1 and 10 is 11, 2 and 5 is 7. I can't get 17 out of that. Oh, I can do 10 and 2 and 5. You can't do that. It's got to be either 1 and 10 or 2 and 5. Here's where you got to remember that I got to get this in the middle, but it's whatever I put here times x, and whatever I put here times 3. Oh, times 3x, not just x. So that means if I put 5 here and 2 here, watch what happens. That gives me -2x. 5 times 3, that's -15. What's -2x and -15? -17. So 3x minus 2 times x minus 5 is the factors of this. Meaning this times this equals 3x squared minus 17x plus 10. Why, Mr. Harrison? I still don't get it. Why am I doing this? Because if you can split up the quadratic and standard form to this intercept form, it's going to make solving equations easier. It's not the only way we're going to learn to solve, though. So if I come over here and I look at an example of why it's going to help me with solving. Actually, let's do one more. Oh, yeah, let's do this one real quick. I'm sorry, guys. I know I switched gears on you there. So we're going to split this guy up just like we just did. The factors of 6 are 1 and 6, 2 and 3. Notice that means my factors of 6, I have choices for this spot and this spot to give me 6. Notice, though, that my factors of 2, the number here and the number here, is 1 and 2 only. So I know it's going to be 1 and 2. It has to be. I also know, because the last number is positive, remember what I told you, look in the middle, that's going to be minus for both of them, because that's the only way to get a negative times a negative is a positive, and help me get the middle negative number as well. But whatever I put here is going to be times -1. Whatever I put here is going to be times -2, but I got to get -13. So use your noggin here, use your brain. I need something that's 13, but I got 6 and 2 here. That means I'm going to have to put something here like 6, because that's going to make 6 times 2, 12. That's going to get me closer to 13. Now, if it doesn't give me 13 when I put the other one here, 1x, 6 times 1, then I'm not going to leave them there. And that's the thing about factoring, is sometimes I call it an educated guess and check. You may have to do a couple of tries before you get the right numbers in the right spots. But it will not work if you don't put 6 here, multiplied by the 2, that's -12, and -1 here, multiplied by the x, -12 and -1 is -13. So, again, why, Mr. Harrison? Because what we can do with that now is we can use this concept that we talked about earlier called the zero product property. If I can take standard form, that ax squared plus bx plus c equals 0, and I can take any equation, even if it's this ugly equation that deals with area. We're going to talk about our little dog pen here in a little bit that we talked about the other day. And I can split this up into factors equal to nothing. Then that means this times this equals nothing. That's the same thing we did when we were finding the intercepts. And we said, okay, if I've got something here times something here, and it equals nothing, I can set this equal to 0, find an answer. Set this equal to 0, find an answer. And yes, those are my X-intercepts, but guess what? Now they also have more meaning to me. They are also my solutions that make the equation equal nothing. So what that means is, if I'm trying to solve this quadratic, when will this thing be 0? If I just gave you this at the beginning of our course, you'd look at it and you go, yeah, right, okay, whatever. Because it's hard. You could guess and check, and you might find some answers. I'm not saying some of you aren't real good with multiplying and stuff and adding and getting an answer. I'm telling you, if you understand that concept that we just talked about called factoring, I can split this up into x and x. That's a -18, so a plus and a minus. And the factors of 18 are 1 and 18, 2 and 9, 3 times 6. Which ones of these will give me 3 in the middle? If you put a +6 and a -3. That means if this times this equals 0, either x plus 6 has to be 0, or x minus 3 has to be 0, because that's the only way it works, guys. If you multiply two things together and you get nothing, one of them has to be nothing. And so then I just take and subtract 6, and I get x is equal to 6. -6, sorry. I add 3, and I get x is equal to 3. Yes, guys, if you think about the graph, that means -6 and +3 over here somewhere. Those are my intercepts of my graph. But I'm not trying to find the graph. I'm just trying to find what makes them equal 0. So I just found my two solutions to my equation here. Whenever you're dealing with this, it's that graph, that x-intercept that we talked about, that actually is the solutions to the equation. Some of you might be thinking, well, Mr. Harrison, what if it's not equal to 0? That's okay. That doesn't change what you do. You still can take this right here and you can subtract the 3x over to this side. That's negative 20x. You can also add the 5 over to this side because that cancels out this, cancels out this. Now it's equal to 0. And 45 plus 5 is 50. Then I can factor this and set the factors to 0. Because if I divide 2 out of everything, it's going to make it easier. Divide 2 out, that's 1x squared. Divide 2 here is negative 10x. Divide 2 here is 25. That means I can split that up again into x and x is x squared. Positive 25, so that means it's going to be minus and minus because of the middle. The factors of 25 are 1 and 25, 5 and 5. So those are the ones that would give me 10 in the middle. Now notice this one is kind of like that one we talked about earlier. You have this times this times this, or in other words, 2 times x minus 5 squared equals 0. That means this right here, x minus 5, has to be 0. That means I only have actually one answer, 5. What does that mean? Well, I got 5 for this one too, but that's still the same answer. Think about the graph. That means that this graph would touch the x-axis over here at 5, and that would be it. That means this one would actually be our vertex of our graph at 5. So when you're solving these equations, you're finding the x-intercepts like we did earlier in the chapter by breaking this equation that's in standard form apart into simpler, easier pieces. Sometimes you'll run into some that are kind of ugly looking like this, where you have x squared on the weird side, like some of you would say. What I would do is I would subtract the 3x over here. Notice I would put x squared minus 3x. Don't put the 3x first. Then I would add the 6 over here to the negative 10. That would give me negative 4. And then I would split this up. Now why did I move it to this side? Because that's x and x. And it's going to be easier to split that up that way. If you move the x squared this way, you'd have a negative x squared you'd have to deal with. It's a plus and a minus because it's a negative 4. And what's the sign? The factors of 4. 1 times 4, 2 times 2. But I got to get a negative 3. So I use positive 1 and negative 4. Set this equal to 0. Set this equal to 0. And my solutions are negative 1 and positive 4. Again, those would be my x-intercepts if I were to graph this guy. But those are also my solutions if I plug into my original equation. So essentially what you're doing is you're taking your original equation, rearranging it to a standard form equal to nothing, and you're finding the place where it is equal to nothing. And guys, that's why I said those intercepts will become very important points for us. That's what they are. They're the solutions that make it nothing. But they're also, because the way you rearranged it, you could also plug them into the original and it'd still work. Let's do one more of those before we apply that to a little word problem. And then I'm going to show you another way to solve besides factoring. So if I add on this one the w squared over here, that is 3w squared. I subtract 23w over here. That is negative 33w. These cancel, 0. Notice on this one I don't have that last term. Well, Mr. Harrison, then I can't do it. You didn't tell me that one. But look closely. I can divide 3 out of both of these. and I can actually divide a w out of both of them, because it would leave me with 1w. Again, think of reversing the distributive property. 3w times w is 3w squared, minus 11, because 3w times negative 11 is negative 33w. You still have this times this equals nothing. So this could be nothing, or this could be nothing. One of your answers would be 11. And the other answer, notice if I divide by 3, gives me w equals 0. The 3 can't be 0. 3 is just 3. So the 3 is not really doing anything out there. But the w could be 0, and it would make this whole equation true. So that is my solutions using factoring. So let's apply this to our little dog pen we had. I'm going to try to save some time here. But our area of our dog pen, remember, was 4 times 6. That was an area of 24 meters squared. We wanted to get a new dog pen that was double that area, so 48 is what we're trying to do. The original dog pen, like I said, was 4 times 6. But what we figured out is that if you do 4 plus some extra fence, 6 plus some extra fence, we could try to make that equal 48. We could try to make that be double the area that it used to be. This is an equation, but it's not equal to 0. So this is where you're going to hate Mr. Harrison, because what you're going to have to do here is you're going to have to actually multiply 4 times 6, get 24. Multiply 4 times x, get 4x. Multiply x times 6, get 6x. Multiply x times x and get x squared. Then I set this up like I did this equation by getting it equal to 0. Like I did this equation by getting it equal to 0. Like I did this equation by getting it equal to 0. I do some work to make this equal 0. So x squared plus 10x. And then if I subtract 48 from 24, it actually gives me negative 24. So I got it equal to 0, just like we've been doing. Then, like I said, this is the part you're going to hate. You're going to hate me. You got to split it back up. Now, some of you are saying, why can't we do it back here? Because it's not equal to 0, guys. That whole little property we're talking about, zero product property, only works if it's equal to 0. If I tell you that I'm thinking of two numbers and they multiply to give me 10, you can't tell me one of the numbers. It could be millions of possibilities. But if I tell you I have two things multiplied to get 0, you know one of them has to be 0. So we split it up again. X and x. Plus and minus because of negative 24. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I got to get 10 in the middle. Don't put 4 and 6. Oh, please? Because it's a positive and a negative, I actually need to do plus 12 and minus 2 to get 10. If you put 4 and 6, it's not going to work. Now, the final step is to set these equal to 0, just like we have been over here on this one, over here on this one, over here on this one, over here on this one. Once we get it equal to 0 and we factor it, we can now get negative 12 as one of our answers, positive 2 is the other. In real life, that means this needs to be 2 meters. Because that means I'm going to add 2 meters of fence to get double the area. So notice that I'm getting double the area, but I'm not having to add double the fence. That's important to understand about area, and that's where these quadratics come into play. You could do this same type of example with putting, the concrete around a swimming pool. You only have a certain amount of money to afford a certain square footage of concrete. And so you set up your equation equal to what you can afford, and then you go through and you solve it the same way. Now, some of you are going to look at these and see all these big numbers and stuff and start to panic sometimes. You're going to see some ugly fraction numbers. And so there is one more way to solve that I'm going to show you. And this way is using something called the quadratic formula. The quadratic formula, some of you have probably heard that phrase before, is how I solve things in standard form without factoring them. It gives me the values for x without having to split it up, which means a really good thing when the numbers get ugly, and especially, really, really good when the numbers are things like this right here, like this equation we talked about, the stopping distance of a car, and we said we've got this ugly quadratic here with decimals and stuff all over the place. If I set that equal to 0, like we have been today in class, by subtracting 80, I can't factor this, and neither can you. No offense. I like you. I think you're pretty cool. But you can't factor this. Neither can I. So what the quadratic formula does is it gives me a way to use the A, the B, and the C from the problem. Remember, their numbers is what they are, to find the solutions. Now, some of you are going to say, well, why didn't you show us this first? Well, because factoring is actually quicker than the quadratic formula. This formula is ugly. It's the opposite of b, or negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Notice right here, if I kind of zoom in on this, I don't know if it's going to let me do this or not, but see the b over 2a? That's the vertex we talked about. The plus or minus square root junk is what gives me these other 2 points, which, remember, are my x-intercepts. And so the vertex is halfway between them. That's why there's the plus or minus. It gives you to the right and to the left of the vertex. And so, again, there's not a mathematician sitting around in a room coming up with this formula. Somebody had to actually solve using another method that I'm not teaching you in this course, called completing the square method. And they found this formula. But all you do is you take the number for b, plug it here and here. You take the number for a, and you plug it here and here. Then you take the number for c, and you plug it here. And you do the math, you do the square root stuff. So I'm going to come back to over here, one of the ones that we already know the answers for with factoring. We already know the answers for this one is -6 and 3. So I'm going to use the quadratic formula to solve this now instead of just the factoring method. So I'm going to write down the quadratic formula again, and then I'm going to tell you how I remember it. You're going to laugh, and that's okay. It doesn't hurt my feelings if you laugh at me. So the quadratic formula, an easy way to remember it is to sing it to Pop Goes the Weasel. I know that sounds kind of funny, but some of you probably know. If you don't know that, go look it up. Go look up Pop Goes the Weasel. Or you can just listen to me sing this formula and you can learn it. So it's x equals -b plus or minus square root of b squared minus 4ac all over 2a. I'll sing it again. X equals -b plus or minus square root of b squared minus 4ac all over 2a. If you use your b value of 3 and you plug it in, you use your a value, which is 1x squared, you plug it in, and you use your c of -18, you can find the answer to this, and it'll give you the same ones we already found. 2 times 1 on the bottom is 2. Inside this radical, this square root, I'm going to have 3 squared, which is 9, minus this 4 times 1 times 18, or -18, I should say. And that's going to give me, what's that, 72 plus 9 is 81. So you're going to have the square root of 81. The square root of 81 is 9, in case you don't remember any of your perfect squares from middle school. This will be -3 plus or minus 9 over 2. What's -3 plus 9? Well, that's 6. 6 over 2 is 3. There's one of my answers. Well, what's negative 3 minus 9 over 2? Well, that's negative 12 over 2, which is negative 6. There's my other answer. You get the same answers. So whenever you are trying to find solutions, you can use this factoring method if it splits up perfectly. If it doesn't split up perfectly, if you've got something kind of ugly, like this ugly equation right here, you can still take out your handy-dandy calculator and do the opposite of 1.1 plus or minus the square root of 1.1 squared minus 4 times 0.05 times negative 80 all over 2 times 0.05, sorry. I'll sing it again for you in case you didn't get it earlier. That's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And I plug in my numbers, and it looks really ugly. I know it. I know it looks really ugly, but this is negative 1.1 on the outside. 2 times 0.05 is going to 0.05 is going to be 0.1. And I got all this junk in the calculator. I may want to take out my calculator and put this stuff into the calculator. So let's look at that. That would be 1.1, and that is squared minus 4 times a, which was 0.05, times c, which is negative 80, and that is 17.21. So I could take that, take the square root of 17.21, and it gives me this ugly 4.148. I'm going to leave those decimals there a little bit longer there. So plus or minus 4.148. Anytime I round, my answer is going to be a little bit off, but now I can take this and do negative 1.1 plus the ugly decimal. So negative 1.1 plus this 4.148, and you may want to add a couple more decimal places there. This whole thing is divided by 0.1, and there's one of my answers. And I can take this guy. I wonder if it'll let me copy and paste it here. Let's see if it'll let me copy and paste. Oh yeah, there we go. And do minus for the other one. Oh, that's a negative. That's not going to help me. Why not? That's the answer. Yes, it is the answer. But the positive 30.48 is actually the miles per hour that this car can go and still stop in 80 feet. So I do this ugly little quadratic formula here, and it gives me the answer even when the decimals get really bad. If the decimals aren't really bad and the numbers aren't really bad, it still works. If you came across this one right here and you were solving this one, and I did x equals negative b. Let's see if we can get this. I don't know if that's even going to fit over there. We'll try it though. X equals negative b plus or minus square root of b squared minus 4 a c, and that's 50 over there, guys. I know that's kind of hard to see. All over 2 times a. You're going to get 20 plus or minus 4 on the bottom. Inside here, you're going to have 20 squared minus 4 times 2 times 50. Watch what happens with this. You've got 20 squared minus 4 times 2 times 50. It's 0. What? That means I'm going to have the square root of nothing, which is nothing. So that's 20 over 4, which is 5. Same answer. Look at there. Guys, that's what happens when it's only one answer. You're going to get a vertex there, because the vertex is only one point where it crosses the x-axis. Now, I don't have time in this course to go over and start talking about the fact that sometimes you can have a negative inside that radical, inside that square root, that gives you imaginary answers. You will see that more in Algebra 2. That is going to be something that happens in some problems, in some quadratics. You get a negative inside that square root, inside that radical. And so it gives me imaginary answers. And that's kind of weird to think about. We're not going to do that in this class. That's not within the scope of this course. So now you have two different ways to solve a quadratic equation.